Good morning, everybody. Welcome to HashiTalks Securely Building. Megs, it's great to see you.
Hi, Jeremy. It's been a while. How are you doing?
I'm doing great. Hey, everyone, thank you for joining us this morning. We have an action-packed agenda this morning of great talks, and I don't want to waste too much time here, but I want to take just a minute to welcome everybody and introduce the MCs, myself and Megs for today. Uh, I'm Jeremy Myers. I'm a HashiCorp ambassador. I'm part of the Denver Hug Group. Uh, I'll be at HashiConf this year. I hope to see everyone there, and we'll be talking more about that here in just a little bit. But enough about me. Megs, tell us a little bit more about you.
Hi, everyone. I'm Meghna. I'm a HashiCorp ambassador as well. And I will be heading to HashiConf this year too. So hopefully I'll meet a lot more of you over there. And I'm super excited for today, Jeremy.
Yes, it's going to be a great day. Megs, can you run us through a little bit of the kind of the requirements for the day and how we want folks to interact?
Yep. So, everybody, if you do have questions or comments, we'd love for you guys to interact with us on the chat. And while you do so, please keep in mind the code of conduct of this space. Please be welcoming, be inclusive, friendly, and patient. We'd love if you guys could definitely be respectful as well. You can review our code of conduct at hashicorp.com/community guidelines as is shown on the screen here. So yeah, let's get started.
Awesome. Yes, and we'll be interacting with y'all in the chat as well. I see many of you on the YouTube stream. So I've got you guys over here. So, we try to talk and answer questions and help out wherever we can throughout the day here. But yeah, so if you're new to HashiTalks, the way this works is we'll have just a little bit of conversation between the talks, very short, 1, 2, 3 minutes here. And then we'll have another talk presenter jump on stage and present another talk. So if you're experienced and you've done these before, maybe you've been a presenter in the past, welcome back. We're glad to have you back. There's lots of good information today. If you're completely new to this, I hope you learned something new today. I hope you take something away that may solve a problem you've been facing. Maybe it'll spur a thought on how to use the HashiCorp suite of tools in a different way, or maybe it just motivates you to go learn something new today, new piece of technology, get certified, sign up for a certification, those kinds of things. So we hope you take that away. I know myself, looking through the list of speakers today, the very first one, which I'm excited about, Microsoft Fabric. If you don't know, this is a new way to look at your data in one big picture. And so being a very new service, a lot of capabilities, especially with AI today, uh, using Terraform to deploy that to our enterprise in a safe and secure manner is a great way to kick off the day. So with that, I'll introduce the first speaker, Rodrigue, who will be talking to us about automating Microsoft Fabric with Terraform, a modern approach to data management. Rodrigue?
I'm truly honored to be here for my very first time for the HashiTalk Security Building. This event is special because it's a place where practitioners from all over the world share not just theory but practical way to make our systems secure, efficient, and future-proof. Today, I'll take you on a journey where automation meets governance, showing how we can go from setting up Microsoft Fabric infrastructure to full deployment in just 20 minutes, maybe less. I will try to do my best. Before we jumping into the topic, let me share a little bit about me. So, who I am. My name is Rodrigue Gengo. I'm an enterprise and cloud architect, Microsoft certified, and I'm a frequent speaker at Event Tech, most of the time in French. Over the past 20 years, I have a chance to work across banking, insurance, and energy and industry, leading projects from secure cloud loading zone to CRM, ERP, rollouts, and complex data platform. My work focuses on aligning technology with business outcome using governance, automation, and security and as the backbone. So With this background in mind, let me explain why today's topic is very important to me as an architect. As an architect, I've been seeing how manual deployment can show down projects and create unnecessary risk, especially in a platform as powerful and complex as Microsoft Fabric. Automation with Terraform is not just about speed, it's about repeatability, compliance, and also the ability to scale without losing control. This topic is my way of showing that a well-structured automated deployment can align with enterprise architecture principle, while enabling teams to focus on delivering value. So we will not talk a lot. We will show you many things. By the way, we will have a demo. I hope I will finish all this activity in less than 20 minutes. So without losing time, let's go to our demo. I will start by open my Visual Studio Code. I think all of you guys have Visual Studio. Of course, I run Visual Studio as an admin. I will just switch my screen. So all of you guys will see my screen. Visual Studio, where are you? Yeah. Let me know if you see my screen. I think now it's okay. So we will spend most of the time during this session using Visual Studio. So let's begin. What will I show you using Visual Studio? Okay. We start by creating a project. So let's go. Because we want to push Microsoft Fabric in the cloud using Terraform, we will try to do things using some tool. The first tool we use is a Visual Studio. So I open my Visual Studio and I will start by creating a project. It's very important because I need a space when I can store all my files. I will say HashiCorp 2025. Okay. It should be my folder. Now I have a folder. So what I will do, I will need one tool I have in my side. Just 1 second. Okay. What I need is to have all the structure of folder and the file required to put everything in the same place. So I will start by creating my structure. For that, I have created what we can call a PowerShell script and also a task that can help me to generate all this structure in one click. So go to Run Task, PowerShell. As you can see, maybe not yet. You have created all the structure I need. We just close this windows. Now I can see I have two stakes. The first one is the platform and the second one in the workload. So you can see all the item we have in this space. What is the difference between the both? First, we need some tool. So Terraform CLI, Azure subscription as prerequisite, and also Azure credential and network access. To set up, we need a folder and a file structure. To generate the file structure, I use a PowerShell script so I can have all the project routes that can help me to implement all my projects. After doing that, I have a fully organized structure that I can show you just to let you have an idea how it seems like. I will put in its place. New file, struct txt. So this is the structure of my project. So what you can see, I have two sides. The first one, it's the platform when we can find all the Azure resources. I mean, storage account, keyboard, for instance, a resource group, and so on. And we also have a workload stack when we will find all Microsoft Fabric artifacts. It will, for example, be workspace, lakehouse, and any other artifact we can find in Microsoft Fabric. That's why I organize following this structure. After saying that, I have some folder and file. What I will do now is just to follow some steps. The first one will be to add a provider. Why we need a provider? It's set up Terraform provider for Azure and random value. Yes, because we will have some name and we don't want to have a name that already existing. So we need to have a suffix using a random value. So this is the rule that our provider will also play. Provider are downloaded when you run Terraform init. So before to run Terraform init, we need to create our providers. We start by platform because we need to have all the stuff in place before to add other artifacts. Now it's okay. I can close. And the second file we will use, it's how can call it? It will be a random because I say we will use a random function to generate a suffix in our code. So I have my files. I can put a random function. If everything's okay, I can save. After that, what I will do is just to add a variable defined setting for the Terraform stack. So we can go to variable. We also add my variable. I can add any other variable if I need. So now we just need to put what I want to use. After using variable, we also leverage on locals. What is local? Locals can combine variable with a random number to make unique names. For example, it's also define local variable using random number and base name. And we set up early so other file can use this name. So the local is just a kind of a variable that can be used locally by creating, combining many other stuff. So I will add my locals. Maybe I will close this one. It just for show you locals. Where are you? I have my locals. Everything's okay. I can close, save, of course. After locals, I will start by adding my Azure resources. The first resources we will add is a resource group. That makes this the first Azure resource in the platform stack, of course. The best practice is to use one resource to group per stack, unless your team need more add, tag, and track resource. What I want to say is just to have a group, an Azure group for the stack of platform, and also an Azure group for the workflow stack. It's the best practice to have a separate resource group for both stack. But for our demo, we just maintain one stack. So I will put my code to, I have my tag, my location, everything, it's okay. What I will do Next. Next, I will need to add a storage because we need to define a storage account and container for Terraform state. The state is the file and will maintain the consistency across deployment. So, storage account, where are you? Yes, I can add my storage account. I have some warning, but I will not close this file. I will just save. I will see later if we have any kind of problem. I don't know yet. And I will also add the keyboard because we will need to have a keyboard for security, and the keyboard should be ready to use. So we need to add it. So keyboards. Now I have my keyboards. Yes, everything seems to be okay for me. Good. We need also to have a fabric capacity. A capacity is just the computer that run on the Microsoft Workspace and so on. So what will we do? Yes, we need to add a capacity. Where are your capacities? Okay. Oh, I have some issue with capacity, maybe just a variable you don't see. I will check it later. So I just save. I will not close because maybe there are an issue. For our demo, we'll use a capacity like F2 because we don't need a very high power of capacity. And the capacity will be sitting before creating any Microsoft Workspace, of course. So after capacity, we will need a outs. What I call outs is just a way to share key resources, details of other stake. What I mean is just we have two stake. We maybe have some information coming from the platform that will be consumed in the workload. To do that, we need to have what we call outs. The file it's outs.tf. So we need to add some information here. Okay. Now, what I say is just make available all this information so they can be consumed from the workload, for instance. Everything is okay. I can save. Yes. So it share key resources, data, and other stake. Output value show also after Terraform A+. So now we have to go more quickly. What we will do is to populate workload stake file. What we need to do that? For Microsoft Fabric, we will install a Fabric workspace. In this workspace, we will have many other artifacts. I mean, maybe a lakehouse and maybe a notebook. And in our demo, we have prepared a notebook that will be installed in our workspace. This is the notebook I have generated with my task. As you can see, it's a very simplest one. It's just a kind of hello world stuff. Yeah, it's okay. So after that, what I need also a provider. Why I need a provider? It's just because I want to set up the Azure provider for the workload stack. With that provider, we cannot communicate with Azure, so we cannot push anything. That's why we need a providers. So I will add my providers. Oh, I already add my providers. Okay. What I need to do? Yes. The provider, okay. This is a provider, okay. It's okay from dev. No, this is okay. I will go to the workloads provider. Yeah, this is the provider of the workload stake, because I already had a provider for the platform. Now it's okay. What I want to do now is just to add remote stale. What is remote stale? Remote stale, it's how I can say it's it's used Terraform remote. We use Terraform remote stake with a platform storage setting. When we setting before, it have to be setting using before platform detail in other files. What we need it. The best practice is to just to check the storage account name after platform setup, and we need also to keep backend setting the same across stack. To do that, we need a remote stale. We will talk about it later. So, remote stale, where are you? Yes, this one. Okay. Now I have my remote stale. I need also a variable. Why we need the variable? Variable different setting for workload resources. We can use variable in a workload. We can also use another one variable in a platform. So it's the same. Now we are looking variable for the workload. Okay. Yeah. And after that, we will need also locals. As I say, local, it's kind of a map platform output to local variable. We need to set this right after remote stale ready. Because remote stale can also leverage on locals. So locals. Now we have our locals. Everything seems to be okay. We can save. Sorry. What are we doing now? We will go to the main. The main, I think it's, in my case, it's the most important file when we can find all the Microsoft Fabric artifacts that we need to push. We have a workspace, item because we need to push a lakehouse and also a notebook. It seems to be okay, so I can close. So what I need after that, and outputs. Why I need an output? It's an output should be created after defining workflow resources, because it's defined. Output should, how can I say, output is used to share workload details, like for example, in our case, the name of a workspace, the name maybe of a lakehouse that can be used in a pipeline. So yes, so we need the outputs. Okay, as you can see, this output will give a name of the workspace. Seems to be okay. I can save. Execute deployment. Now I'm supposed to be, it's supposed to be good. I can deploy my environment, but I need before that to check some things. Before that, I need to check something. No, this one. What I need to check. Yeah, I can find I have some issue in this. Yes, what is it? Maybe the provider are changed, so we need to change also the way we instantiate this stuff. Yeah, as you can see, change the storage name. Now we have to use the ID, not the name as it was before. Something we can correct quickly. We have another issue here. I don't know what is it. What is it telling me? because I have Microsoft Copilot. Maybe it can help to fix. I think maybe I haven't set the value of SQ. I think we also need the capacity and yeah, we need to add another value here. Yeah, the chairs. I can add the chair right here, but I can also add the chair outside. I think for the chair it should be fabric. I don't know. But we can also follow the same pattern. So we will say this. Okay. And now it will ask me to add this variable. Because it's a variable, it's better if I can add it at the same place as is it for other variable. So it's here. I have my new variable that can help me to fix the issue I have. Can save, of course. I still have a problem. I don't know what is it. I will check. Yes, we need to give a value, I think. I think. What is it? Okay. Fix again. Maybe the value is not the yes default standard replaced with the appropriate default value. Okay. I think standard is not the right value, so we need to check. I think it's fabric. I'm pretty sure. It's something I need to check. It's something I need to check. I can fix it quickly. Okay. It seems to be right. What I see, we have the SKU, we have also the chair, and we need to have also the default variable fabric capacity chairs. Okay, and the default variable, it's a standard. So, as I say, I will put it with other variable. Now it's okay. So, at this time, I have all my variable capacity chairs. What is it? Default standard replace appropriate default value if needed. Okay. I think it's not this value. So explain. It can help. Okay. Now it's okay for me. Ah, okay. Yeah, we didn't put it in the same place, in the right place. It's just the reason. It's the reason. Now everything is okay. What we need to do now is to execute our code. To do that, we need to check I have not value. Maybe I need to Sorry, I have not this value in mind. I need to check it. Where can I find it? I need to connect to Azure, of course. So where are you? Azure. Need to go to my Azure account to get my tenant ID, also my tenant ID. Where are you? Yes, I have my tenant ID. Can use it. You will also ask me subscriptions. Yes, look, so I think it's okay now. No, we need a bracket. I have my tenant ID. I will also need a subscriptions. RM. I think it's RM is this one. Also, I need to go to Azure to take my subscriptions. It's not something you can find quickly. Yes, I think I got it. Where is my subscriptions ID? Okay. Okay. Now I'm pretty ready. What I need to say is to go to my platform, share. And before to do that, we need to make some change. I will just change my resource group because I don't want to have the same name many times. I'm pretty sure random suffix, okay. Where are locals? Local variable. Do I have a resource group somewhere? Yeah. Resource group, I will call it resource group 2. And now I think for me, everything it's okay. What I have to do is just to Terraform init. First of all, I hope it will work because we are close to the end. We need to fix something. What is it? Fan query, okay. Could retrieve list of available version provider. No. All modules should specify the required provider. Okay. What I'm talking about? Share. No, we are not in the share. We should be in the platform. Okay. It's okay. Okay, local. Okay, provider. Okay, maybe I have a mistake into the provider. I need to check something. Need to check the provider. Okay, sorry, guy. I see it's a half of hour. I think it's the end of the time I have to make my session. But I have not finished yet. But I will try to record it and to show you this process on my channel, maybe on LinkedIn. So thank you. And if you have any question, don't hesitate. We have to respect time. So, guy, I'm very sorry. My goal during the sessions is just to show you that we can implement, how I can say, a Microsoft Fabric project using Terraform in a simplest way without taking so many time. What we have to do is just to use a task in Visual Studio, maybe a PowerShell script to generate all the structure. What we have to do after that is just to copy some snippet of our code so we can put all the stuff together to push our infrastructure as a code in the cloud, and also to add all the Microsoft Fabric artifact we need. So thank you, guys. See you soon. Bye-bye.
Thank you so much, Rodrigue. It was definitely nice to see how HashiCorp Terraform has been making the provisioning and management of these Fabric resources. So really a lot to learn. Thank you.
Yeah, yeah, Meg, it was great to see that the provider itself is up to date and ready to do all these new and cool resources. I have to give a shout out to the Azure RM provider team. I know many of them, and they've done a great job with keeping us up to speed with the latest and greatest resources. A couple things I noted there, right? Just some good best practices. Separate your state into several workspaces. Control your blast radius. Don't pile all your resources into one state. This will bite you. If not today, tomorrow. I deal with this on a daily basis. I have meetings later today to talk about this with some of our early adopters to the cloud and how we can kind of migrate them to a more of a micro state, if you will, set up instead of a monolithic state. So very good best practices there. I was actually shocked to see how few lines of code it takes to deploy Microsoft Fabric. So I'm excited to go and check that out and try it. And what I think we saw a glimpse of some Copilot or GPT in there as well, giving some hints in the VS Code terminal. So that's cool to see as well, integrated with our Terraform HCL language.
Yeah, and that being said, I would like to do an announcement now about HashiConf. For those of you who don't know, HashiConf is HashiCorp's annual global cloud conference, where a lot of experts, platform teams, leaders, and executives from all around the world gathered in person and online to share how products in HashiCorp's product stack has helped them, run their business applications. So the conference is going to take place in San Francisco from September 24th to 26th, 2025. I think if I'm not wrong, there is still some time to register. So please do visit hashiconf.com. And of course, you will be seeing all of us over there. So just want to dive into the next topic, and this is something that's the core of reliable infra as code, right? Which is Terraform state management. So our next speaker is going to walk us through how to keep state secure, scalable, and very team friendly using Azure. So let's welcome our next speaker, Christos.
Hello everyone, I'm Chris Galanopoulos, and today we're going to go over a session for managing Terraform state in Azure. So, a little bit about me. I'm a solution architect at Performance Technologies in Greece, and I'm also a Microsoft MVP in the areas of DevOps and infrastructure as code. You can find me on my website, where I regularly post about infrastructure as code, DevOps, cloud, and various other things. LinkedIn, GitHub, where I have open source some tools and repository templates. Medium, for a bit more, let's say, sophisticated and philosophical articles. And of course, Sessionize to schedule sessions where I can appear on your own podcast, event, workshop, whatever. So let's start with a bit of a refresher. Terraform, I believe we are all familiar. It's an infrastructure as code tool. It's a declarative resource for provisioning. It helps us manage infrastructure efficiently and automate deployments with reproducible configuration. Now, why does Terraform need state? It essentially needs state to map real-world resources to configurations for accurate tracking. This way, we can ensure that we follow the correct order of operations, we reduce API calls, and improve performance at scale. And it's a really efficient way to detect drift and maintain a history of changes. So we need to be able to track what does our current infrastructure look like, what modification do we aim to do, and what does that implicate for those modifications. So before any operation, Terraform refreshes that state to align with real infrastructure. And it's our responsibility to maintain and do operations through Terraform and keep state up to date and being able to reflect our accurate environment, meaning we need to avoid handling things both manually and with state without having explicit ignore clauses. Otherwise, our state will get disrupted. But I'm sure a lot of these are also really well-known facts since this is HashiTalks and we're talking about Terraform. So we use Terraform, we know why we need state. Where do we put it? Of course, we are testing locally or just starting out. Local would be the first option, just to see how things play out. But that cannot be, let's say, our default choice when we are actually using it in production. And in production, I'm also incorporating all other developments, meaning that we're having a workload that we want to maintain and handle its life cycle through Terraform. So we need a remote storage, kind of with the same logic like why we use remote repositories with platforms like GitHub or GitLab. And we cooperate with other people and multiple people have access to it and we can update it from a centralized location. So this way we're not, let's say, having things like it works on my machine or my local file was deleted and now we can't do anything. It's stored in a remote location. And this way we can enable team access and versioning and we can prevent data loss by leveraging, as we will see, cool stuff on cloud with data replication, and we can have more granular control and security. Now, where would you want to store your state in Azure? And how would you do that? Of course, there are a lot of options on where you can store your state, especially if you are using multiple cloud providers, but Azure Blob Storage is a reliable way to do so. It's a reliable backend for Terraform state, and it provides very cool features like high availability and scalability. Logical that we want is built-in locking. We want to prevent race condition and conflicts. So when we're modifying state, we don't want to allow simultaneous operations resulting in a race condition where we don't know what happens and that disrupts it. We can leverage the role-based access control and encryption to have secure access. We can lock down our network with private endpoints. And we can have also, like I said, with the availability, but also for disaster recovery scenario and other stuff like that, we can have backups and also geo-redundant storage for resilience. So we're covering a lot of our bases. I would say at the max that somebody can do, because nothing is perfect, but we hit pretty close to perfect by following this approach with all this feature. So Azure Blob Storage is a really cool option where you can store your state in Azure, and it provides a lot of baked-in features that you can leverage out of the box. So let's say we're going to store our state in Azure. How would we design that? The first approach, and I believe the most simplistic one, would be a project-based state management. Here, as you know, blob storage requires for you to have created an Azure storage account. So in this approach, we have a storage account per environment, meaning each environment gets its own dedicated storage account. This provides full isolation, allows separate access control per environment, increases management overhead, but it also has higher costs due to multiple accounts. So if we want to visualize this, let's say we have one project still, but it has three environments. We have our development environment, our quality environment, and our production environment. Most likely, we are using a service principal for the deployments, like a service account that has the necessary permissions to deploy these resources and do the modification, not through a personalized account of a user. And then we need three storage accounts with three containers, where each of those will handle a state file. Now you can imagine if we're using storage account for other purposes as well for each environment, that's not too wasteful. But if we only need the storage account to store the state file, you can imagine that this is like a really ineffective solution cost-wise, because we're having 3 storage accounts just for a single state file. The second approach would be, okay, we're still with one project, but instead of having 3 environments, meaning one environment for each, one storage account for each environment, we're going to have one storage account for the whole project. Okay. And we're going to simulate the environments through containers, meaning we're going to have 3 containers because we have 3 environments. This is easier to manage. It's more cost effective. It has reduced isolation, of course, with the per environment storage, and it requires that we apply role-based access control at the container level, meaning that the development service principal should not be able to modify the state in the production container. Okay. Whereas before we applied it on the storage account level, now we need to apply it on the container level. But this way we're more cost effective. We have one storage account, we have our state files into different containers. Each service principal gets airbagged on the appropriate container, and this is more cost effective and easier, let's say, to maintain because you have one resource instead of 3. Okay. A different approach would be to try and centralize state management. And what do I mean by centralization? We follow some core principles. These core principles entail we have a single storage account for all projects, just one. This might sound like is one enough, but we're going to find out that it's more than enough. And we're going to have a dedicated container for each project. You can try and let's say have the parallel from before where we went from 3 storage account to 1 storage account with 1 container per environment. Here we're going 1 level higher in the abstraction tree. We just have 1 storage account and each project gets a container. Now, a very valid question would be, okay, but how do I apply permissions on different environments under one project? And we're going to find out pretty soon. But a little teaser, we're going to do this with custom role-based access with conditions. Of course, our initial assumption remains that each file is linked to a dedicated service principal, meaning what we want is a service principal that has the necessary permissions to, of course, do all the demodification that we do and also register those in the file. For example, if we have a project called Project X and it has an environment called dev, we're going to have a service principal for that environment. That service principal will have all the necessary permissions to do the deployment, the modifications, the deletions, whatever, and to be able to modify that state file and only that state file. We don't want to allow modifications of other state files for obvious reasons. Let's go over some scenarios. Scenario 1, single module. Each environment has a dedicated service principal. So we have n service principals for n environments. This ensures strong isolation. It maintains a clean and scalable architecture, and it's simple to manage with least privilege enforcement. So if we try to visualize this again, we're seeing we have, let's say, again, one project, let's say it's project X. We have 3 service principals, 1 for each environment. You can see here the Terraform state contributor. It's a custom role that we apply on the storage account and the container that we're going to showcase in a bit. And then you see we have the project container, and then we have a condition called blob path condition. So essentially, we are virtualizing or simulating a hierarchical namespace inside the container. So we have the main container, and below it we have virtual subfolders, which are the environments. So it would be project X /dev /Terraform TF state. And we would give permissions to the development service principal to be able to modify only the files under project X /dev, similar to QA and production. Unfortunately, or fortunately, however somebody looks it, role-based access control can only be applied on the container level. So we're going to leverage another cool functionality of Azure Storage Accounts and Azure, let's say, identity management in general, that's called attribute-based access control. We're going to see about it really soon, but first, let's clarify again. We have three main scenarios. We modify the state in an allowed path, like I said, project X, dev, Terraform TF state, then we are allowed to do so. If we try to modify a state outside our allowed path, for example, the QA service principals tries to modify the project X dev Terraform TF state, it's going to get blocked. It does not have the necessary permissions. And of course, we don't allow any delete of state files. We don't want to delete the state file. If you see when you do a Terraform apply with the delete option, it just goes back to a relatively empty state file with empty resources. That's what we want. We don't, this is explicit. We don't want to delete the file itself. Or we don't want to do it through the service principal. Perhaps we do it at a later stage for administrative and maintenance and housekeeping, but we don't want to do it through the service principal itself. Of course, here I'm saying modify because you might have multiple modules and you want to read the state file from other. This could be allowed. I mean, reading a state file, it's not that big or disruptive as modifying one. We need to be able to modify only the state file that we are linked to as a service principal. Let's move on to the second scenario, which is multiple modules. Here, each module has its own state file, and we require separate service principal for each environment. So we have n times m service principal, okay, where n is the number, let's say, of modules, and m is the number of environments. This, you would say, why would I do this? Because you might have different teams handling different stuff. Let's say we want to deploy a workload that consists of different components. We have a network component, we have an application component, we have a database component. And these, let's say, components, their Terraform code is written by different teams. The workload is one that needs to operate. And we have, of course, dependencies among the components. But this, we don't want to, since it's being developed by different teams, each team should have its own state file. So again, we are under one project, but we have multiple modules with multiple environments. And this is, of course, for very complex scenarios with multiple teams and modular infrastructure, but in enterprise level, we should be able to support it. And with this design, we can support it relatively easily. So this way we have enhanced security through module level isolation. Like I said, we cannot modify another team's module, we can just read it. And this requires the trade-off is more granular access control. If we see our visualization, you see it's like the same from before exactly, but now we have a service principal for each module environment, let's say, combination. Of course, like this is if you want to take it to the extreme. Another approach could be, okay, I have one for the development, and this is allowed for all modules. But again, it relates to how many different people work on their own scope. The safest approach and the most optimal would be this. It seems verbose, of course, but this is the most secure and, let's say, least privileged approach. So for the development environment, we would have a service principal for each module. For example, network, database, application. And then under the project container, project X container, since we have a virtualized hierarchical namespace, we can simply append to the path. So the SP for dev module 1 would be able to modify the Terraform state file on under only project X /dev /module 1. It might be able to read the state file from module 2 or module 3, and most likely it will need to. For example, our database might have a dependency on the network module. It will need to go and read the state from the network module in order to be able to set things up, because it assumes that there is a network. But it will not be able to modify its content. Okay, enough on the design. Let's see how this would get implemented. First of all, we need a custom role. We need a custom role called Terraform State Contributor. Here we see the custom role. It's just a JSON. You can copy paste it. I will also try to share this key presentation as well. And essentially, what it does, it has a role name, a description, an assignable scope. Here, the assignable scope is, for example, if I'm deploying in the subscription with the HIT. And here we see what permissions are allowed. We are allowed to read the container, to write a container, to have generate the user delegation key. And then we have some data actions to read a blob, which is essentially a file, to write to it, and to add, to create a new file. Okay, what is a conditional role assignment? A conditional role assignment is an additional check that refines role assignment for more granular access control. It's like we're saying, okay, you have the Terraform state contributor role, but I want to add some conditions to where you can apply this role or where you can use this role. And only if these conditions are true are you allowed to perform an action. So the idea here is to use condition to narrow access from the container level to the blob paths. And this way we can enforce, like we say, the blob path namespace for even finer control. Whereas Azure with just the role itself allows us to go only at the container level. Here's the Terraform implementation for it. It's rather straightforward. We get the reference to the Terraform state contributor role definition, which we have created. We get a data reference to our storage account and to our container. So we have the storage account, the container, for example, for project X, and our role. And then we're saying, okay, perform a role assignment. Of course, we need the blob reader in general in the storage account to be able to read. And then we need to have a role assignment that's conditional. If you see here, we have some conditions. And the condition says, if the actions that you're trying to do is not, it's a bit confusing, the logic, but it's how it works, is not writing to a blob or creating a new blob, creating a new file, or so you see we have end in these two, or the path string starts with. So essentially this might seem complicated. You can just copy paste this, but what it says essentially it is allow write operations or creating new file operations only if the blob path starts with, and then we have our config blob path. So here, for example, it could be /dev /module1. So do not allow this service principal that we are assigning the role of Terraform state contributor to do any write or add actions unless the path that it tries to do that action starts with dev module1. And we have starts with because we need to be, let's say, a bit flexible in the future. Okay, and here are our variables. We have the access config variable, which essentially takes an object ID. It's a service principal that we are assigning the role, and the blob path, the path under the blob container where the service principal should have read-write access. And then we have some storage info, which is where is our storage account, what is its name, what's the container, and what's our subscription. So if you go with airbag and ABAC in Terraform state management, we need to clarify this thing, like I said, using conditional access and conditional role assignment is essentially the attribute-based access control. We have the role-based access control, which is the role itself, Terraform state contributor, and we assign it on the container or the storage account level. And then we have attribute-based access control, which says if those conditions are true, or if these attributes are true, then you are able to perform the actions defined in that role. So the role-based access control assigns permissions on predefined roles, like the Terraform state contributor or the storage data blob reader. It enables least privilege and simplifies access management. And the ABAC, the attribute access control, it extends ABAC with dynamic context-aware access control. And this you can use it for other things as well, not just blob path. You can have very sophisticated conditions. And this is implemented through conditional role assignments. So this way we can restrict access by blob path within containers and limit access based on attributes. For example, our blob path, it could be resource tags, it could be user properties, You can even add your own besides the block path if you want to have a sophisticated combination. So when you combine airbag with ABAC, you have a robust, scalable access control, which enforces least privilege, and it's easy to scale and, let's say, take into account context-aware information that relates only to your use case and organizations. So going back, which approach should you choose? Project-based or centralized? For storage, the project-based, like we said, we have multiple accounts. For centralized, it's just a single account with multiple containers, one for each project. The setup in the project-based is really simple, whereas in the centralized, it's complex, at least until you get the hang of it. And here, side note, you just need to get the hang of it. Not everybody consuming it. If you provide the service principal to a team to do the deployment that has access to the state file, you just need to provide them with the backend information for the storage account and the container. And of course, the path to the key. For example, if it's /dev /module1 Terraform TF state. Other than that, they don't need to understand really this complex logic. They just need to have necessary permissions and then information to use the backend. Other than that, they can treat it as a black box. You would be responsible, you meaning the platform team, the DevOps team, the administration team, if it's centralized, because centralization means that there are a centralized team or people that have the ownership of this thing. The cost, of course, is significantly lower with centralized. And because you're using geo-redundancy and backups, you can easily, smoothly not have the issues of, okay, if my storage account disappears, what will happen? It will not disappear. You have geo-redundancy, you have backup, you can quickly spin it up. You might have some downtime, but you can plan for it. The cost for the project base is significantly higher, especially if you go with one storage account per environment. That will show up, especially if you're using also private endpoints for the networking, the cost will pile up. So project-based is best for small teams, whereas centralized is best for large team and enterprises. Wrapping up, some key messages of this session. Remote state storage is essential for team collaboration and reliability. Azure Blob Storage provides a robust backend with built-in locking and security. There we have two main patterns. We have the project-based, which is simple, and the centralized, which is scalable but complex. We need to choose based on scale. Small teams go with project-based, whereas enterprise go with centralized. Of course, if you have a small team, you could also go with centralized initially. For me, it's worth it, to be honest. But you have to, let's say, adjust to that learning curve initially for the maintainers and the operators. The centralized approach uses custom airbag and conditional assignments for fine-grained control, which is the ABAC, like we said. The bottom line is you need to plan your state management early, because if you start and things keep piling up, the migration will be harder than you can imagine. So if you start with project-based and you have like 100 projects, and each project, let's say, has 3 environments, we're talking about 300 state files. Now, these 300 state files might be under 100 storage accounts or 300 storage accounts. And migrating all those into a centralized storage account with proper permissions for the service principal and paths and conditional assignments, it's a bit tedious. So it's better to plan ahead. This essentially wraps up today's session about managing Terraform state in Azure. I hope you find it useful. To be honest, when I was researching about it, it was a really pleasant surprise to find out for attribute-based access control. This is just one use case that you can do, but I believe it's very powerful, and that you can, by centralizing the state and having smooth, let's say, vending machine kind of like permissions assignments to the service principal that do the deployment, you can have this run smoothly. Of course, design it initially, create the automation initially, but then run smoothly for everybody. And you can achieve high levels of automation, scalability, and of course, this is like perhaps not the perfect solution, but it's really good in terms of security, from a security perspective. It enforces least privileges. You only allow people or service principal to read from where they're supposed to, and of course, modify only the state file that relates to the deployment scope that they are responsible of. So this wraps up my part. Thank you. I hope you find it useful, and until next time, enjoy your day.
Yeah, thank you so much, Christos. I really loved the talk. Personally, I haven't explored Azure much myself, so this was really cool for me. I also really liked the key messages at the end. It somehow put like all the takeaways at one place, and I'm sure we took away ideas that we could all put into practice. So please drop a thank you in the chat for the speaker and hit those reaction buttons to show your appreciation.
Yeah, Meg, that was great. I I've frequently heard people say, hey, you should store state in, Azure or AWS and the storage side of it. I've never really stepped into it to look into it too much. But the one thing that always concerned me was security. How do I control the state and who has access to it? And he kind of brought to light the RBAC controls and the custom RBAC roles that could be built within at least Azure. You could do similar roles in AWS as well to protect those. So that's really cool. That was fun to see. Quick announcement before we go to the next speaker. Just remember, we'll be sharing all of these talks on the YouTube platform in about a week's time. Those should be showing up. So if you missed anything, if you want to go back and rewatch something or share with colleagues, just know that in a few days to a week, we'll be sharing those out to that platform. So that's good for everyone. Up next, we have Eric, and he's going to be talking about bridging AI and Nomad, which is an area that I don't have a lot of expertise in. So I'm extra excited to see how he does this. And building a Go-based MCP server for cluster control. Sounds interesting.
Hello everyone, I'm Eric Kochi, and today we'll present a project that brings together artificial intelligence and Nomad through MCP server developed in Go. So the goal is to create an infrastructure that allow AI system to interact with external tool in a standardized and secure way. In particular, I will show you how this approach can help automate real-world tasks inside a Nomad cluster, making infrastructure more dynamic and reactive. So we can start just a few words about me. I'm currently a master's student in computer science at the University of Bologna. I'm passionate about DevOps, automation, and cloud technology. And right now I'm in Nice, in France, completing my master thesis, which I will finish it in October. Alongside my studies, I've also worked on several open source projects, especially in the field of infrastructure, orchestration, and some AI tools. You can find me on LinkedIn or GitHub if you would like to check out more of my work or get in touch. So let's begin by briefly defining what an LLM is. So a large language model like ChatGPT, Cloud, or Gemini is trained on a massive amount of text data and is capable of generating natural language and answering complex questions. This model have transformed many fields from content generation to code assistant, but they also come with important limitations. For example, they have limited memory, so they can forget information provided early in a long conversation. They can generate hallucination, meaning they may invent data or cite non-existing sources. Their knowledge is static, so it's limited to what they were trained on, so they don't know anything that happened after their last training. And they are also prone to bias and reasoning limitation. Because of this, using them in a critical or production environment can still be risky unless we add more control and awareness to their behavior. This is exactly where AI agent come into play. This, unlike a simple chatbot, an AI agent can access private content like files, database, personal note. It can also fetch real-time data like stock price, the current weather, or breaking news. And last but not least important, it can perform actual operations such as calling an API or modifying configuration or comparing dataset, for example. To enable all this through, we need a standardized, safe, and modular way for AIs to interface with the outside world. That's where MCP comes in. MCP stands for Model Context Protocol. It's a standard proposed by Anthropic in November 2024, and it works just like a USB port, connecting LLMs to external software in a simple and pluggable way in this case. This means we can extend our LLM with new capability without modifying them, simply by using a shared interface that both sides understand. So, before diving into how the MCP primitive works, which are prompts, resources, and tool, let's take a quick look at the overall architecture of the protocol. And actually, it's pretty simple. We have the hosts, which are program or IEs that want to access the data, such as Cloud Desktop or even IDLE like Visual Studio Code, Cursor, ZED, assuming they support MCP. Then we have the clients, which create a one-to-one connection with the server. And finally, we have the server, like the one I've developed, which expose and execute external functionality according to the MCP standard. In my case, the server is directly integrated with the Nomad API, and it also provides a web interface to interact with the cluster. Later on, I will show you a live demo so you can see this all in action. But now let's look at all the three main primitives of the protocol. In particular, we start with the prompt. Prompt are simple instructions or template that guide the LLM on how to perform a task. So, in the example show, we define how the model should interact with the user. So in this case, we are saying the model should say in a friendly tone by greeting them. But we could just use another prompt to instruct the model to give more quantities or more detailed answer, depending on the use case. So yes, next we have the resources. That the resources allow to load mod documents such as project documentation, which the model can consult when needed. In this example, we uploaded a basic file, but we could just easily load a CSV file, a full directory, or a database dump. The model can then use the data when we ask it to perform tasks or answer questions related to the content. This expands the model context without retraining it, just by injecting relevant external information. And finally, last but not least important, we have the tools. The tools are actual functions that the model can invoke to interact with the external system. For instance, it could launch a Nomad job, retrieve the status of one location, or delete a variable from the system. These tools are modular and configurable, which mean they can easily adapt to different domains, from DevOps to security or to data science. In the code, you will see we first define input validation. We specify which fields are required, their type, and provide a short description. Then we move on the implementation, which in this case handle the 4 operations of a simple calculator. So we have the addition, the subtraction, the multiplication, and the division. And all of this is returned to the LLM, which processes the result and give us a human readable output. The great thing is that the model doesn't just call the function, it explains the result, interprets the data, and can even suggest follow-up more action. So now that we have seen all the 3 primitives, now let's look at the basic MCP configuration, which is just a JSON file, and in it we define the server name, the command the model should use to run the server, its argument, and any environment variable. In my server, we have 2 key environment variables, the Bootstrap ACL token use it if the Nomad have the ACL enabled, and the Nomad client URL, so the model can communicate using the Nomad API. This setup makes the server portable and easy to deploy in different environment. But now let's see a real-world examples of how we can use the MCP server to automate practical tasks. In this demo, we'll be interacting with a Nomad cluster directly using a natural language. So we begin by sending a simple prompt asking to initialize the ACL token and show it to us. Then we deploy a web application, specifically an Nginx server with 2 instances. We check the application log, we wait for deployment, we scale it to 3 instances, and finally we ask to a link to verify that everything is working. So let's dive to the demo. Yeah. Okay, so as I said, we initialize the CL, create the deploy of the web application, we check the log, we scale the application, and finally we have the link of the Nginx app. So let's start. So we stop the ACL token. We allow for this chat the execution of the tools. Okay, now we have the secret ID, which we are copying it in the clipboard to use it later in the web interface of Nomad. We are creating a deploy. We are deploying the application with 2 instances using Nginx. And after we are checking the log as we said in the prompt, and we are seeing if all is deployed fine. So now the job is in pending state, so the model understands that should wait a little bit more. Okay, we also checked if the node is available, so it's doing some troubleshooting way to understand why it's not deploying the instance. Okay, we are checking again the deployment, which now is running. Okay, we are checking now the status to check if all is working good, in particular the allocation. And in this case, yeah, you see an issue about the deployment because there is a constraint about that require Consul 1.8. So he updated the job specification without this constraint, and now we try to deploy the application, and this time works. So we have 2 allocation running. Perfect. We check the log if all is fine. Now we scale the application to 3 instances because actually we have 2 instances, so we change just the parameter count to 3. Okay, we check if all is fine. Yeah, from the logs, yes. And finally we get the link, we paste the secret ID, and all should be work. So now we check the link, and yeah, we have the Nginx app deployed without doing nothing, just using the natural language. So we can continue here. Okay. Okay, in this slides I have also included the GitHub link to the project if you'd like to explore it more further. Currently, the server supports various functionality, including listing node, checking job status, viewing allocation, creating and deleting variables, policies, and interacting with just house volume actually. But in the future, I plan to add more features like plugin support, monitoring hooks, and multi-agent coordination. I've also started working on a Consul MCP server, which is still a work in progress. You can also find it pinned on my GitHub profile along with the roadmap of the planned feature. Thank you for the attention. If you're interested, the code is available on GitHub, and feel free to reach it via email or Telegram if you like to discuss the project, propose collaboration, or just share ideas. It's been a real pleasure to present this work to you. Thank you again for the opportunity, and I hope more like this will follow. Thank you. Bye.
Wow. Was that cool or what?
That was amazing. I never actually got into MCP, so I think it was very cool just seeing how that works and the kind of challenges that you could encounter with this. So really, it was great.
Yeah, that was so cool. I've got to find him and hit him up online and ask some questions because that was impressive. And now I think I want to go learn more about Nomad. I think I can do it now.
Yeah. Okay,
Very good.
I'd like to go and introduce our next speaker, Kevin, and he will be speaking about Terraform module breaking change detection. So I'm actually looking forward to this as well, especially because I think he's gonna explore like how, how not to break changes in your code and how to build tooling around Terraform tests to surface more of these issues. So yeah, let's welcome Kevin.
Hi everyone, and welcome to HashiTalks 2025. Today we're talking about Terraform modules, and more specifically, how to detect breaking changes before they hit the production. We'll explore how the Terraform test framework can help us compare versions and make upgrades safe and predictable. I'm Kevin Andrieux. I'm working as cloud engineer at Lenstra, and I'm part of HashiCorp core contributor community. I've been working with Terraform for over 3 years now, or from small companies just getting started to massive deployment, supporting them into all their challenges. And trust me, I've seen what happens when a breaking change slips through. And big part of my experience comes from my work at Lenstra. We help company bridge the gap between business and technology, delivering services that covers AI, data, infrastructure, cloud, and security, especially in sectors of luxury, finance, and insurance. We follow a product-driven approach, which means we build solutions with the same rigor, scalability, and quality you would expect from a product, not just a one-off project. Terraform is at the heart of how we build and manage infrastructure for our clients. And over time, we have created a large ecosystem of modules to make deployment consistent, scalable, and secure. So let's set the stage and talk about the life of a Terraform module. It usually starts small. Day zero, just solving a specific problem for one project or one team. Then comes day one and beyond. More features, more customers, more edge cases. And that's when maintaining stability becomes a real challenge. As adoption grows, so does the risk of introducing a breaking change that could disrupt the other teams. That's exactly why we create modules in the first place, to avoid chaos and make infrastructure predictable. They give us reusability, so we solve a problem once and we can use it everywhere. They can bring consistency, applying the same standards across the environments and the teams. They allow for scalability, making it possible to roll out changes to many deployments at once. They add an abstraction, hiding the complexity so the teams can focus on what matters. And then they foster collaboration, giving multiple teams shared blocks to build their infrastructure. In other words, modules are our Lego bricks for infrastructure. And as the Lego comes with different colors and produces different shapes, we encounter the same thing with Terraform modules as we grow. Every team has its own specific use case and will contribute to a different block of your Terraform infrastructure. What are the breaking changes? It's all the changes that forces a manual intervention to upgrade successfully. It can go from renaming a variable, renaming a resource, or renaming the outputs. It can be as well modifying all the arguments that could trigger a resource recreation. In the Terraform ecosystem, we usually follow semantic versioning. The idea is simple. Major version means that there could be breaking change in the version. Minor version can add new features but should remain backward compatible. and then the patch version, which should fix bugs without affecting the behavior. In theory, this helps us to know when a change might break something. In practice, it only works if you actually detect those breaking changes before releasing the new version. Let's take a simple example, like a Lambda module. At first, it's pretty straightforward. It's clean, reusable block that solves one problem really well. Then teams start to adopting quickly because it's reliable and easy to use. But we start upgrading version and adding features. Maybe in v1.1 we introduce something new like code signing. No problem, we can make it code backward compatible. Then v2 comes along and we remove a default public internet access to improve security, for example. And suddenly we introduced a breaking change. On this case, we have detected the breaking change and released a new version mentioning that a manual intervention is required. The danger is when those breaking changes slip through unnoticed. Everything might look fine in the new code, but when a team tries to upgrade, the plan fails or worse, resources get destroyed unintentionally. On this example, we can think about what if we have made the code signing mandatory? It will require an intervention on all the teams that will upgrade to v1.1 by signing their code. On this case, it's not a big problem, but it can be quite fast a mess. Consequences can be more serious than this one. It can be failed applies, like on this example, but it can be unexpected infrastructure change. That results on more manual testing and longer review cycles, and ultimately less confidence in the stability of the modules. As countermeasure, maintainers often add new conditions to improve security and compliance, and that's good. But human guardrails can still fail, especially when usage grows. The classic way of testing modules is manual. You clone the repo, you run Terraform init, plan, apply, and you check manually if everything works as you intend. It's slow, it's repetitive, and it's easy to miss something. One improvement we can make is shifting your usage example directly into the module repository. That way, you can test modules in a real-world scenario and ensure the example you publish are actually working. This also makes it easier for users to see the official use case directly where they get the module. By keeping usage examples inside the module repository, you can run them regularly to validate your module. It's a first step toward the automation, but we can go further. This is where the Terraform test framework comes in. It allows us to define scenarios as code and declarative way, specifying the variables as inputs, and you can specify assertions for outputs. Instead of manually running multiple plans and apply, Terraform test does it for us in a clean and repeatable way. When we run Terraform tests, Terraform will handle the plan, the apply, the assertions, and the destroy steps. And at the end, we get a clear pass or fail result, and we know the infrastructure works as intended in a one-shot environment. But here's the catch. Testing only the latest version tells us that the code works now, but it does not tell us if it's safe to upgrade from an older version. Without that backward compatibility check, breaking change can still slip in and hit the users later. The real power comes when you use Terraform test to run the same scenario from two different versions of the Terraform codebase. Example could be a reference version like v1 and testing it against the new feature candidate version, like a new branch or a PR. You can then run assertion comparing the outputs or checking resource ID or attributes. You will be able to change the changes that migrate the user before the new version ever ships. Here is what it looks like in practice. We define two run blocks with our test file. One run block for the candidate and one for the reference code base. Both will use the same variables as input and the same state key, so they operate on the same infrastructure context. As you can see, the reference will use the reference code source path, and the candidate will use the default one, which is the working directory. On the reference path, we will have git cloned the reference code. So let's say we would have git cloned the v1 version of the module. Here's what the execution looks like, and let me show you in the real world. Here we have an example of a Terraform module that is meant to create an AWS S3 bucket. On this demonstration, we have chosen to have to propagate the naming convention of the S3 bucket. We have a resource prefix which is determined for all the company with a default value, and we have the bucket name which is chosen by the user. And then we output the complete bucket name after the AWS S3 bucket has been created. Let's get to our tests. Here is the reference test. We test it against one source, which is called reference code, where we would have git cloned the content of the repository on a fixed version, let's say v1. On the reference run block, we have the variable block, which contains all the variables that we want to test with. For example, with modifying the prefix and setting the bucket name to HashiTalks 25. Then we have the candidate run block. We don't set the module source path because it will use the working directory as default. We have set as well the state key to match the reference state key and the exact same variables. But we added an assertion condition at the end. We want to make sure that the bucket name does not change between two runs. So we added the condition between the run reference block and the output of the candidate. It will show an error message if this condition has not been met. So let's run the Terraform test right now. We will run first a Terraform init to download the provider and initialize the backend. And then we run a Terraform test. So it will run first the reference, which has passed. And now it's running the candidate, which has passed as well. And now it tears down the whole infrastructure, so it will destroy the S3 bucket. It has succeeded. Great. So now let's imagine that a contributor comes in and says, I want to add something to the naming convention. Let's say adding a team variable. He will create the variable and says this variable is optional and it's set as string. So he will set a default value of an empty value. As first glance, we can say that the variable in the output is a default. There's a default value, so we don't have a breaking change, but we'll check in actions. Let's run the Terraform test again. The reference still passes as it used the old version of the code, but it seems that the assertion fails for the candidate. And the explanation is quite clear. We see that the reference bucket name has changed between the reference and the candidate execution. As you can see, there's an extra dash in the bucket name, as you can see here. So it will tell the contributor that the bucket name has changed between the reference and candidate run. Then it tears down the bucket and says that it's a failure. This gives us a lot of possibilities. You can have a generic reference candidate sample test, as I shown in the example, and you can have resource ID comparison and output values comparison. This is really important because right now we're using more and more AI to contribute on our modules, and it accelerates the delivery. But sometimes we want to have gatekeepers. AI can propose code changes, but Terraform tests should decide if those changes are safe to release. If you would like to continue the conversation, share feedback, or dive deeper into Terraform testing and breaking change detection, feel free to reach out. You can contact me directly or connect with our team at contact@lenstra.fr. We are always happy to exchange ideas with fellow IIC and Terraform enthusiasts. And if you're passionate about AI, data, infrastructure, security, or cloud, and you like the idea of product-driven approach to build solutions, Lenstra is hiring. We're looking for people who enjoy solving real-world problems and are not afraid to tackle complex challenges. If that sounds like you, feel free to apply. And that's it for today. Breaking changes are inevitable, but with the right tools and practices, like Terraform test and multi-version comparison, we can catch them early and make upgrades predictable. Thank you all for your time and attention, and I hope to leave you today with ideas you can apply with your own Terraform workflows. Enjoy the rest of HashiTalks, and let's keep building safer infrastructure together.
Awesome. So such good information there. As someone who writes modules for our app teams and our cloud engineers, there's nothing that worries me more than breaking previous versions, right? Our Terraform code is just like application code that we need to stay current on the versions of the modules that we're running, but it's hard to do that sometimes. So there's always people lagging behind a version or two or three versions behind. And as we roll things forward, as we introduce new provider versions, we always want to make sure that we have backwards compatibility on those. So such a great talk, good information there, great recommendations around not just testing your current code, but the previous versions to make sure that your customers will not see issues or errors the next time they run their plan because of a breaking change that was introduced. So very good talk there, Kevin, and thank you for all that information. The next talk, we've talked a lot about building. It's time to show some love for the security side of the house, right? So let's introduce or welcome Sarup Kumar Pandey, and he's going to be talking about red teaming the vault in Kubernetes. Take it away.
Hello everyone. Thank you for joining this session. So we are going to discuss around the attacking and defense for the Kubernetes from foreign to secret and how we can secure using HashiCorp vault. Let me start with the introduction first. Within this agenda, we are going to discuss about the threat landscape, recon with Sudan, Kubernetes exploit, then secret and extraction in the wild, and defense playback with the HashiCorp vault, and then key takeaway. If take an example, imagine this. You are sipping a coffee on a Monday morning, and somewhere across the world, a stranger is using a search engine for hackers to find your computer secret, and they haven't even touched your fire wallet. And today, the same thing today, I am going to showcase you the exact how that possible, step by step, and more importantly, how to make sure it's never happened to you. Let me take you around the attack scenario that we are going to look. So, before that, let me introduce myself. I am Saurabh Kumar Pandey, Associate Engineering Manager at MIQ Digital, and I am having a 6 year of experience with the penetration testing, red team, and the defense mechanism for the cybersecurity. So why this matters? So first the thing is like misconfigurations, Kubernetes and secret management. And because of it, there are lots of the real world use cases like exposed database, list token, and unprotected vault instance. And all of this, if we merge together, then attacker do the automation and discover the exploitation part and then do the attacks. So let me walk you through the attack scenario. Every modern organization uses a Kubernetes and some form of or secret management, often a bot. But the reality is these systems are only as secure as their configuration. If you misconfigure Vault or Kubernetes, you are basically putting your keys in a glass box labeled do not touch. Today, I will show you an attack chain that starts from the outside, nothing but the internet, and ends with me holding the sensitive AWS credential. And I will flip the table and show you how to stop it. So that scenario is very simple. The journey follows a logical chain, starting with the external recon, then moving into the Kubernetes, escalating the privilege, finding the extraction secret from the vault, and think of it like a game of climbing walls. First, we find a way into the yard like recon, then we sneak into the house, which is Kubernetes, and then grab the master key like privilege escalation and open the safe vault secret. Even a step is realistic. Each and every step is realistic and replaceable in a lab or in the real world, and sadly, all too common in the wild. So the first phase, as we know, like external recon from the Sodan query. So Sodan search engine, like is a hacker search engine where you can find all the details related to exposed assets. And if I am attacker and my step is recon, I don't want to scan the internal internet myself. Too slow and I might get caught. Instead, I use a Sodan search engine that's already scanned everything by searching for the vault and port 8200. I can find the server that shouldn't be visible, and in my demo, I will show you your mock showdown output to expose the vault server, and each of them potential allowing access to sensitive data. And imagine this as the front door left open and wide open, and you have to get inside it. So let me show you first showdown. Okay, so let me open it. And let me go to the Sodan search query. So here I have entered the search query HTTP title bold port number. You can also define your company name. So based upon your company name, it will search and give you the result. If something is open and exposed, you can find the vulnerabilities around it. You can get sneaking into it. So if I open any of the vault, so let's open it, and you can see like all the post detail are here. And if I go to the 800, like it is showing like Vault is running on this particular app port number. If I click here, it will redirect to me on UI. But here, what you have to do, you have to find the dashboard which is unauthenticated, and then only this thing attack will work. If this is not unauthenticated, in that case you have to find the vulnerabilities revolving around the CVE. So if I go to the another vault, and let's take some more example of the vault. So let's go anyone, let's check it. And wow. So here you can see like in 2023, still this CV, this is vulnerable, and based upon this CV, you can perform the attack and take the access. And not this, just look for the more results. So let's this vault. Let's look into this. And again, you can see the CVE associated with this. So if you want to explore more, let's go inside it more, and let's click this vault. And no, there is no CV, it means it is safe. And let's open this, and again there is nothing related to CV. And let's look more. Like this. So this is how you have to look for the look into the Sudan and you have to find an authenticated dashboard, and based upon the Nomad, so whatever the vault, HashiCorp vault is there, you can use that and you can identify the issue around it, and then you can perform the attacks. So I suddenly I have found one of the attacks in one of the vault, and then I decided why not look into the CV and look how attackers do. So here I see the CV associated with the vault and all, and you, if you want to exploit it, you can go and definitely you can go and do the unauthorized exploitation or based upon the CV and the version, or you can also do some search on Hersey exploits CV uh, CV, and then you have to look for the working POC, then do GitHub. And you will find there are lots of CV, working CV available on the GitHub, do the privilege escalation attacks and all kind of stuff. And based upon that, just look around it, go try and hit the like do the privilege escalation. Let me help you to understand how you have to do it. So let's go back to again the PPT and let's look into how you have to do. So first thing is external econ that we have seen how you have to identify the detail for from the soda, and then pivot into the Kubernetes. So the first phase, as I told you, I'm an attacker and this is the way I will do the recon. And then once I find the weak spot and exposed dashboard, I pivot into the Kubernetes, and I have simulated an insecure dashboard that doesn't require authentication. This is like walking into a building where the receptionist just wave you and in without checking your badges. And from here, I can lead the pod, read the secret, and more. But the main thing is like how you have to connect once you get the IP of your victim uh, dashboards, right? So you have to run the command kubectl with the proxy, then define the IP, and then with the asterisk you can look into this, and then it will give you the access. And once you get the access, the next step is to do the privilege escalation. So it means begin inside the Kubernetes agent is not enough. I want more power. I grab a service account token from the default namespace, which often has a more privilege than it should. And with this token, I can impersonate a more privileged user. In some real breaches, attacker use this exact trick to gain a cluster admin rights, and which is likely getting the master key to the entire building. So once you inside the Kubernetes, you want to increase your level of privilege, right? So just run the command, grab the token, and use this token to call like API which has a higher privilege user role, right? And then once you call the token, then you can have a broader permission entire cluster. And yeah, it means like escalation is like privilege is escalated. Now you are admin, you can do anything. So if I can do anything, what I will do? I will first extract the secret from the vault. And to extract the secret from the vault, here is the command. Just do the curl, define the token, define the IP of the asset, and then define the APIs through which you want to access the CRED. And it will give you the details of entire secret and the static long-lived secret. If it is there and you can use it, and then it will not even expire. You can maintain your privilege for the longer period of the time. And now that I have a more flavor, I can talk directly to the vault. Its vault is misconfigured and my token has access. I can pull entire secret. And if this credential are long-lived static, they can be used indefinitely, like anytime, anywhere, from any place of this world, and giving attacker the more control over the cloud access. And yeah, the more part is Terraform. So I haven't added the Terraform in this PPT, but let me give you some examples. Sometimes you don't even know the need not don't even need to know the attack vault. Secrets are lying around in Terraform state file, right? And this file, if it committed to Git and may have a plain text credential inside, a quick search on the public repo can uncover keys that open production system. And yeah, so the file name will be the .tf state with embedded AWS key. And again, once you get that, then entire game is done. Like you are boss of that particular network and you can do anything. And just to stop that attacks and all, so you can lock down the dashboard with RBAC, enable the bot Kubernetes auth and short-lived secret, then block the vault exposure with network policy, and then rotate the and expire the credential automatic. And most of the organization I have noticed, like rotation expiration of credential takes time. There can be the most of the circumstances, like client is there and you don't want to revoke your key, you don't want to rotate your key because it's a business requirement. So there can be the multiple scenario, but you have to find a way to work around, right? So maybe you can use a Sodan, or you can use other tool which can help you to identify your exposed asset over the internet. And also, like if I talk defense mode, like stopping the attack, for every attack step there are countermeasure, right? And Vault can be integrated with the Kubernetes to only issues a short-lived dynamic credential, making a stolen secret unless after the minute. And Kubernetes are back, and the network policy can lock down the dashboard and block Vault from the public internet, and continue monitoring with the Sodan or other tool which can help you to detect your dashboard before attackers do. So, automated, how you can automate security isn't just fixing the misconfiguration. It's about knowing when something changed. And with the Sodan API, you can automate the scan for the vault, consoles, and Nomad exposure, right? This all thing you can get into Sodan and trigger alert in the Slack and take immediate action. Like, and think of it is as a smoke alarm for your circumstances. No, it's your task. I will like if you like go to the Sodan, create your account, search for the console and Nomad, and you will find, definitely you will get at least one dashboard open to the public, and try all these steps that I have given to you, and you will find like lots of data you can extract from the one place. And then this is a defense mode. Just write a one like Terraform. It will expire your TTL after 1 month or something like that, and you can rechange it again and again. And yeah, this all. And you have any doubt, you can reach out to me over the LinkedIn, here on YouTube. You can ask me the questions, and I will answer you. And this is the way how you can protect your organization. This is the way how you can protect yourself, your secret from getting leaked on to the internet. So yeah, I know I like this is 30-minute uh, session, and I have taken less time. And yeah, so this is very hard to showcase entire exploit. So I have given you the exact what the step needed to perform this attack, and how you have to follow this approach. And definitely, if you follow this approach, you will find the vulnerabilities around your secrets. And I have seen most of the organization, like developers made mistakes, and all human do. So it's quite a general, right? So if you have something in your dev environment and you don't want to make it public, you generally use a Helm chart to make something public in your environment. And in Helm chart, you define the load balancer as a public. And if someone by mistake, if they make it private, or sorry, by default you use private, but by mistake, if someone made it public, then again your dashboard will go live without username and password, and anyone can access, right? This can be one scenario. So there are multiple scenario around the world. So I will like if you go and search for all your vault details over the Sodan, using your company name, using your personal name, and something like that, and try to protect it from attacker before they do it, right? So thank you everyone.
Thank you so much, Saurabh, for that talk. I don't know about you, Jair, but for me, this particular topic was something I knew the least about. So just going through that end-to-end attack scenario, and figuring out how Vault could be used to defend against those attacks, that was something that really caught my attention. And also, I don't know if you noticed, but it kind of really talked about both the offense and defense strategies. So I think that was something really interesting as well. Or what
Yes,
was
that
your
was
favorite
great.
part? Yeah. Yeah. I'd like to introduce our final speaker for today, Pradeep Kumar. He's going to be talking us through how to build secure automation pipelines and secrets management with HashiCorp Vault. So, yeah, take it away.
Hello everyone, I'm Pradeep Kumar Palaniswamy, and today I'm gonna talk about something that's often overlooked in automation, securing the way we handle the credentials. The session is called "The Last Secret That You'll Ever Hard Code," and I'll walk you through how we can protect our automation from hidden risks using the HashiCorp Vault. I've been, in quality engineering and automation architecture space for over 17 years, working primarily in highly regulated financial services. That means I'm used to operating in environments where a single, security slip, like an exposed API key, can have huge consequences, right? I've had the opportunity to lead enterprise-wide vault adoption initiatives, and what I've seen is that securing automation pipeline is not just about the compliance. It is all about building the trust in our systems and protecting the customer data. What drives me in the area is a passion for building secure, more scalable automation frameworks, right? And we often focus so much on the functionality, so much on the performance, so much on the coverage, but we forget to ask, are we storing and managing these secrets the right way? And if we are not, then that's the gap that we have where attackers are more than happy to exploit, right? So in this session, I'm not just going to show you a Vault as a tool. I'll take you through the real world automation scenarios where insecure secret handling is at a risk, and then show you two live demos, that real world use cases. The first demo A will focus on how we use Vault in everyday lower environment automation, and demo B will show you a more advanced setup for production-like environments where compliance requirements are, very strict. By end of this talk, we all should walk away with a clear understanding of the risks we face, how Vault helps us eliminate those risks, and how we can take these patterns back to our own teams, right? All right. The next one. So before we jump into Vault, let's talk about the problem. Most automation engineers don't realize it, but our scripts often carry secrets, like I said before, API keys or database credentials or access tokens. And because automation is designed to run hands-free, these secrets often end up in plain text, embedded in test scripts or config files or CI/CD pipeline variables and whatnot, right? Where do these risks hide? Three most common places I would say is one is your test scripts and config files, sometimes hard coded right into the code. Anyone with repo access can see them, right? The next is the CI/CD pipeline variables. We assume they are safe, but they can still be exposed in logs or screenshots, or even in a misconfigured permissions, right? And the next I would say is the local dev or test environments. Developers or testers may store credentials in plain files on laptops, which are much easier to compromise. Now, why is this dangerous, right? So because all it takes is only one exposed to secret to open the door for attackers, right? So if that secret is tied to a database, an API, or even a staging environment that has production-like data, you have essentially handed them a key, right? And in many industries, especially like the one which I work, the financial services, this is not just a technical issue for sure. It is a compliance and regulatory violation. You you are at a risk exposing personally identifiable information, PII, triggering security breaches and facing potential fines if applicable, right? We have seen real world examples where the threat actors found exposed secrets in public GitHub repositories and used them to access private data. So these incidents are not very rare. I would say like they are happening every day. You all might have seen it. And importantly, attackers don't even care if it is a test environment. If it is connected to something valuable, they'll for sure exploit it, right? So the takeaway here is in automation, secrets are everywhere, and unless we actively manage and secure them, we are operating with an open door to all these potential breaches. So that's exactly the problem HashiCorp Vault is designed to solve, and that's where we'll go next. All right, moving on to the next one. So now that we understand the risk of hard coding secrets, let's talk about how HashiCorp Vault changes the game for test automation security. So Vault is, I would say, essentially our central nervous system for secret management, right? So instead of having API keys, passwords, test credentials, SSNs, and tokens sitting in multiple places, like code repositories or Jenkins variables or even someone's laptop, we store everything in one secure encrypted location. So that means there is a single source of truth for all our credentials, right? One of the Vault's biggest strength is that it doesn't just store secrets. It can generate short-lived or dynamic credentials. Think of it like a hotel key card that expires the moment you check out. So in our automation pipelines, that means no more static passwords that linger for months or years. A test can run or request a secret from Vault, use it for just few minutes, and then it's automatically revoked. That this drastically reduces the window of opportunity for anyone trying to misuse that secret. Another powerful capability is environment specific access control, right? So in our demo itself, in demo A, which I'll show you shortly, we'll focus on a lower environment scenario where automation jobs need certain credentials, but we don't want every job to have a free access, right? So Vault lets us define app roles and policies that tightly control who gets what. Even in non-production, we make sure only the right team can get the right secret at the right time, right? So then followed by demo A, we have another demo B, which talks about a production-like environment where compliance requirements are very stricter. Here, the app role setup is even more fine-grained, ensuring that CI/CD jobs only access production secrets if they all meet the policy requirements, right? And every single access is logged. So if a regulator asks who accessed the secret last month, we can easily pull the data instantly, right? The audit trail is not just nice to have in regulated industries, but it is an essential one, right? And Vault also integrates seamlessly with CI/CD pipelines. So instead of storing the secrets in Jenkins or GitHub Actions, our automation code just makes a quick call to Vault during the job, retrieves the secrets very securely, use it and moves on, right? So nothing gets committed to the code. Nothing sits around in pipeline variables and nothing is left behind for someone to accidentally find it later, right? So as we move into these demos, think about how this applies to your teams. So demo A is about reducing the risk, in everyday lower environment automation, and demo B is about meeting the toughest security and compliance standards in production-like environments. So together, they show how Vault scales from simple use case to enterprise-wide security. let's jump into the demo. So let's fix a problem, where most teams quietly live with shared, long-lived database passwords and test region, right? Those credentials end up in config files or CI variables or even in screenshots. So they are very hard, to rotate and easy to leak, right? Now I have a demo here, and I have db underscore demo.js file. Uh, what it does is, it authenticates. First, it authenticates to Vault using an app role. That's a machine identity. That's safe for CI and automation, right? And the second is it asks Vault's database secrets engine to mint a brand new Postgres user just in time for this run alone, right? And then the third is it connects with that user, then waits for the lease to expire and tries again to prove the user was revoked automatically. And right here we log in with the app role, and then um, we have this iTest role. Think of us like a pipeline proving who it is. So Vault returns a short-lived token. So we never hardcode tokens. Vault issues them on demand, right? And this, this call the database creds iTest role. Vault talks to Postgres and creates a real database role on the fly. So with a strong password and a TTL, time to live. And when the TTL expires or ends, the role is revoked automatically, right? So let's try it in action. And if you look at this one, so we are logged into the Vault and we have been issued an ephemeral DB user with short TTL. So we can see the expiry quickly. While we're waiting for the token to expire, let me explain what's happening behind the scenes. Right now, Vault has dynamically generated a set of database credentials for us. These are short-lived, meaning they are valid only for a fixed period. In this case, I've used, I think, 70 seconds. Yes, where is it? Yeah, 70 seconds. And this one, this is one of the Vault's strongest security patterns. Instead of having long-lived credentials sitting around in config files or hard-coded into code, we request them on demand, and Vault hands out a fresh set every time. And once the time to live or TTL runs out, Vault automatically revokes them in the database. So that means even if someone captured these credentials right now, they would be useless in just few seconds. So in real world deployments, these TTLs might be 30 minutes or an hour or even shorter for high security environments. The important thing is you don't have to remember to rotate them, right? So you don't have to store them. So what we are I think it just expired and gave us a message as expected, expired, user failed. That's what we got. And what this means is, for a team, no more static database passwords in code or CI. So every run gets a least privilege access, that gets self-destructed, and rotation and cleanup are automatic. and every credential request is audited in Vault for compliance. So this, one shift removes a whole class of, secret sprawl from the test automation. Now let's move on to the next demo, demo B, and take a look at the data protection. Sometimes our tests need to handle values that behaves like a PII, say an SSN, right? So code paths are realistic. But letting lower environments store or print plain text is a policy and a compliance nightmare, right? So we set a lower environment policy that can encrypt only, and a prod-like policy that can encrypt and decrypt. So this script, logs in as lower first. It sends a sample SSN to Vault's transit engine. So the transit, doesn't store the data. It's encryption as a service. So Vault, returns the ciphertext and prefixed with Vault v1, right? And that ciphertext is what the lower will use in logs and artifacts. So safe to store and safe to transmit. And then lower tries to decrypt and gets blocked by the policy. Even if a lower runner is compromised, the attacker only gets the ciphertext, right? And finally we switch to prod-like identity with decrypt rights. So same ciphertext in, but plain text out. So under strict controls and fully audited, right? Let's quickly run it. And we see that encrypted SSN returned as Vault v1, that's lower doing the encrypt only, and decrypt blocked in lower with 403 as designed, I would say. And the production like decrypts, okay, we get the original value back from the back for the approved checks. So that's the beauty here. It's the separation of duties. A lower can process data, but never possess a plain text. Only the right identity in the right environment is allowed to decrypt. So every encrypt and decrypt is logged in Vault's audit trail. So we can answer who accessed what and when. Exactly what the auditors want. So let's put together with demo A. We have now seen two high impact patterns for the automation. So ephemeral access to the infrastructure, no long-lived passwords, and the second is the privacy by design for any sensitive data. Encrypt where you develop and decrypt only where you must, right? So both the patterns keep your teams fast and your pipelines clean, and of course the auditors happy. Let's move on to the next one. Before we look at how Vault helps, let's talk about the reality without it. First, we often see hard-coded secrets in the automation scripts. So this is a critical security risk. If that script is ever leaked, so are the credentials, right? So second, the secrets that make their way into Git history are almost impossible to erase completely. Even if you delete them in the latest commit, older commits or the folks can still reveal them, right? So third is storing secrets unencrypted in configuration files or environment variables is like leaving the keys under the doormat, right? So anyone with access to the system can potentially grab them. And the other thing is when credentials are shared across teams, there is no clear accountability. So if something goes wrong, it's impossible to trace who used them, right? And finally, long-lived tokens or passwords are attractive targets for the attackers, right? So the longer they live, the more time an attacker has an option to exploit them. So this is exactly where Vault, steps in. It enforces short-lived secrets, centralizes the management, and gives us, secure access control, so we can avoid all these, pitfalls. All right, let's move on to the next one, the benefits. So when we talk about test automation, one of the biggest security gaps we see is how secrets are handled, right? Like we have seen before. Um, this risk, this is risky, storing the credentials in config files. If the code is pushed to a repo, even a private one, so it can be exposed. So Vault, like I explained, Vault eliminates this risk completely. And with Vault, credentials never live in the code. Instead, our automation simply calls Vault during the test execution and retrieves the secrets securely. And it also dynamic, short-lived secrets. Static secrets are like leaving your like I said before, the leaving your house key under the mat, right? And we have the centralized management and CI/CD integration. So Vault acts as a single source of truth for all environments: dev, QA, staging, even production validations. So instead of juggling multiple credentials, stores, everything is centralized and controlled. So this also integrates seamlessly into our CI/CD pipelines. Jenkins, GitHub Actions, Azure DevOps, and you name it, right? So that means no matter where our test runs, the process for fetching the secrets is identical. And the other is granular access control and also the auditability, right? So we can define exactly which team service account or the test suite can access a specific secret, nothing more, nothing less. And every access is logged. This is a huge for compliance, because if something goes wrong, we can trace exactly who accessed what and when. So for example, in our every time Jenkins requests a secret, that action is logged in Vault, giving us a full audit trail. By combining all these benefits, no hard-coded secrets, dynamic credentials, centralized management or tight access control and complete visibility, Vault gives us a secure, scalable, and automated way to handle the secrets, especially in the test automation. It is a security best practice that also, saves engineering time. All right, let's move on to the next one, challenges and best practices. When adopting Vault for test automation, the benefits are huge, but so are the challenges if it's not implemented, thoughtfully, I would say. Over the past few months, we have seen where teams can get stuck, and through our demos today, I'll also show you how we have addressed these pain points in our automation pipelines, right? The first hurdle is the initial learning curve. Vault's concept like authentication methods, namespaces, and policies can feel, complex at first, especially for teams coming from, static credential management, right? And the second is managing the access across environments. The second, I would say, is managing different environments, dev, QA, staging, and pre-prod without risking cross-environment credential leaks, right? So in our setup, we used Vault namespaces and dedicated secret paths for each environment in demo 2, right? Sorry, demo B. This means a staging job cannot, accidentally fetch a product secret, something we'll walk through, we walked through in our demo. And the next is handling network latency or downtime in CI/CD. So Vault downtime or network latency can block an entire test suite. So this is a real risk. So, um, you know, uh, secrets are prefetched and cached securely for duration of the pipeline is a good option, minimizing the dependency on live calls during the test execution, right? And balancing the security with speed. There is a tension between strong security and fast automation always. Dynamic short-lived secrets are secure, but they require extra calls to the vault. So, I think in demo A we addressed this by setting a short-lived TTLs for high-risk secrets. Um, you know, but also caching the low-risk test credentials temporarily for faster runs. Always with the audit log enabled will help us. And the best practice, use vault namespaces or dedicated paths for the test automation, and implement least privilege access with the short TTLs. Even if in case it is compromised, a secret is useless after a short time, right? And integrate Vault agent or sidecar for the automated retrieval, which removes the need for manual secret fetch logic in tests. And the other thing is rotate secrets regularly, even in non-production. Because the stale secrets, the test secrets are still at a security risk, right? And then we can say like the test vault failover in pipelines. So you don't want to discover a failover issue during the production release window, right? So by acknowledging these challenges early and applying these best practices, we have been able to make Vault a seamless part of our test automation pipeline. And as you'll see, as you've seen in the demos, these are not just theoretical. They are running today in our Jenkins build, ensuring both security and speed. Thank you all for your time. I hope this session gave you some practical insights. Um, you can take it back to your own projects. So if you would like to continue the conversation, share feedback, or discuss ideas further, please feel free to connect with me on LinkedIn. The link is right here on the slide. I'm always happy to exchange thoughts and of course learn from the community. Thanks again, and I look forward to staying connected.
Excellent. Thank you, Pradeep Kumar. What the age-old problem of secret zero, right? We can always rotate, encrypt, and automate all the future secrets, but there's the initial secret, and where do we keep it? How do we keep it? Those kinds of things. So HashiCorp Vault can help you get rid of that secret zero and make your entire process more secure. And you can sleep well at night knowing that that secret isn't leaked or compromised. Or as Carl said in the chat, a shared secret is no longer a secret. So very true, very good demo, and really hammering home the point that we've got to all be security minded to take care of those secrets. Thanks.
Yeah, I really liked the presentation too. I think there were a lot of insights about how to build securely from day one. So a lot of takeaways from there. But I'd like to take a minute to do an announcement for HashiConf. So HashiConf is HashiCorp's flagship cloud conference, and it's going to take place from September 24 to 26, 2025 in San Francisco, California. So there is still time to join us. So please be sure to register today and visit hashiconf.com for more information.
Yeah, and if you're on the fence about should I go, I'm not sure, you have to. This is a great opportunity to get hands-on, directly in front of the product teams, talk technical, dig in the weeds on those hard, complex problems that you're facing, or make recommendations for new capabilities and enhancements. Also, there's always lots of ambassadors there, like Megs and myself, we're always willing to talk and just hang out, talk about whatever you want to talk about in terms of the HashiCorp products. So it is a great time. It is probably the best conference I've attended in all the years of going to conferences in terms of just the ability to meet folks one-on-one and have a good technical conversation. Folks are readily available throughout the day in the hallways. Also, there's hallway talks that are outside of the stage presentations that are short, 10, 15-minute presentations, quick hitters on different topics. So those are always good to hit. Yeah, I always find myself running around because like, oh, I got to go hear that one. I need to go see this one. I need to go talk to that person. At the end of the day, I'm 20,000 steps and really exhausted.
Yeah, I think there are so many different tracks and sessions to choose from. Also, networking events and lunches, especially for the community of women. So I think really a lot of people to meet there, and I think you can get certified there as well. So
Yes.
there is in-person certification. So I think just getting that done would be something great as well. And if you do want to connect with other practitioners and community members locally, be sure to check out if there are any user groups near you. You could always visit hashi.code/hugs to find a hug near you. And if you find out that there is no hug, you could definitely reach out to hugs@hashicorp.com to learn how to start a hug. So that being said, I would like to wrap up today's event. We do have day 2 of HashiTalks happening tomorrow. So I think that's going to be happening from 10 a.m. EST tomorrow, as in August 14th, for those joining from different time zones. We do hope to see you tomorrow, and like to also take a moment to thank the entire team for coordinating this event so well. So yeah, thank you, and see you all tomorrow.
Thanks. See you, everybody.